arc or arrow, and the other one is AON, that is activity on node, right? And I told you we will stick to one method for a certain time so that we will not get mixed up. So by now we have a good idea about the activity on arc method, that is AOA. We have seen how to construct, how to do the forward backward computation, everything. Now this is the time we can see the activity on node kind of network construction. So suppose this is a precedence table, right? So you can construct both the using both the approaches. You can construct the network. But today, let us see the activity on node type of construction. Right. So, what is the difference between these two methods? The difference is that in the previous method that we have discussed, we have used each and every arrow being representing an activity, right? And the circles or the nodes are nothing but the start and the end of that activity. That's something like events. Compared to this, when you are using the second method, that is the AON, so as the name suggests, now the activity is on the node, right? Node means those circles. So if those nodes are representing the activities, then what are the arrows? There will be arrows, but those arrows has the only interpretation that it is showing you the relationship, precedence relationship, nothing else. The arrow is having only precedence relationship. That okay, after completion of this activity, you can start that activity. So just the relationship is represented by arrow. So the node or the circles are now representing activities. Okay. So just look at this table. I hope you are able to see these slides. So this is activity precedence table. There are A to F activities. Their durations are given. Just like your previous examples. So it is a precedence table. And suppose we are asked to construct the activity on node kind of. So of course, in the side you can see, I have also mentioned that you can construct the activity on arc for this also. I have already shared the PPT with you yesterday. You can go through this later on. These are all part of your module 4. So to construct the activity on node kind of thing, as you know, let me show you the result of this. Okay. So for that table, this is the result. This is the activity on node. Alright. So you can see there are blocks. Okay, there can be circles also, or you can use the kind of blocks or rectangles like this. So for each and every activity, you can see there is a block is marked like A, B, C, D, E, F. Another difference you can see, we are using two blocks which are calling as start and end, which was not there in activity and arc type of method. But here in AON, we have to use a start, right? We have to use a start and one end, which are used for this case. Apart from that, you can see these arrows, these blue arrows have no meaning except the precedence relations. For example, let me pick anything. Anything means, suppose the D, activity D, the predecessors for activity D is B and C. Okay, so you see here, look at activity D. You can see from C and B, two arrows are going and merging at the activity D. Right? So that is just showing the precedence relations. Similarly, we will construct the AON kind of approach. We will start with a block which we will call as start. Then we will look into the various activities. For example, activity A, it must not have any predecessor, right? A does not have any predecessor. So obviously you have to start from activity A. Right? Similarly, B का predecessor A रहा होगा, तभी A से लाएंगे. Similarly for C. So you can do it once the concept is clear to you. Either it is AOA or AON. You can construct it. Right? It will require the same effort for this case. Now, coming to okay, this is another example for this AON kind of situation. This is a little bigger for computer application. So you can see the same format is there. You will have activities, you will have their durations, and you will have processes. So if this is constructed in activity on node, it may look like this. Of course, this is part of some software, so it looks a bit different, right? But the meaning is same, right? The meaning is same. You can see a block which is marked as A. Of course, there is no start there, but you can have a start in the beginning. So from the start, you can have arrows to A, B, C. Right? The start and end is missing here. But when we are doing it manually, there should be a start. Okay. Now, there are a little bit more details are given in this blocks, as you can see. For activity A is given what is the start, what is the finish. Of course, it is in terms of dates. So as I said, it is part of the software. So some more details are given. But you can check the precedence relationships must be matched. Let me pick anything. Like H. The predecessors are D and E. So just see what is H. Yes, H is here. So you can see H का predecessor में आपका D और E है. Okay? D और E. So the same thing. You have to I mean, make it compliant with the precedence relationships. It has to satisfy, obey all the conditions, and you can construct it. Okay? So this is the construction part. Now let me share you another file. It's a PDF. I will share a PDF file, which will have some more details about this AON. Right. So just give me a second. What is the difference in terms of some sign conventions when you are using AON? That I will discuss. Okay, so can you see a new file? That is a PDF file.
Yes, sir.
Okay, so let me explain it. Suppose you are using activity on node type of construction approach, then there will be another difference compared to the AOA. If you remember, AO केस में हम क्या करते थे कि जो नोड के पास हम सिर्फ दो ही वैल्यू लिखते थे एक ब्लॉक बना के, है ना, yearly start, let start, right, which are representing early and latest, earliest and latest. बस दो ही वैल्यू कैलकुलेट करते थे हम, फॉरवर्ड पास और बैकवर्ड पास. बट व्हेन यू आर यूजिंग AON में एक डिफरेंस आ जाएगी कि आपका हर एक सर्कल या नोड या रेक्टेंगल जो आप बना रहे हो नेटवर्क में, दैट इटसेल्फ इज रिप्रेजेंटिंग एन एक्टिविटी. और एरो का कोई मीनिंग नहीं है, एरो इज जस्ट अ रिलेशनशिप, प्रेसिडेंस रिलेशनशिप. तो जो साइन कन्वेंशन यूज होता है आपके AON में, इसको आप थोड़ा ध्यान से देखिएगा. लुक एट दिस सर्कल, यहाँ पे एक सर्कल, हाँ ये सब सर्कल बना हुआ है, आप देख सकते हो, हर एक एक्टिविटी को एक सर्कल. Now look at this circle. इसमें आप देख सकते हो, this circle is representing one activity. ठीक है, क्योंकि एक्टिविटी नोड. जैसे आप देख सकते हैं इसका मीनिंग कैसे रिप्रेजेंट करना है. एक सर्कल ऐसे बना के उसको ऐसे 4 क्वाड्रेंट में डिवाइड कर दिया है और बीच में ऐसे एक ऐसे इस टाइप का बना हुआ है. there you can write the name of the activity or simple. मान लीजिए आपका एक्टिविटी ए आप रिप्रेजेंट कर रहे हो सर्कल, तो एक्टिविटी ए लिखोगे और उसके नीचे उसका जो एग्जैक्ट ड्यूरेशन, हर एक एक्टिविटी का ड्यूरेशन है तो वो मेंशन करो. जैसे यहाँ पे 2 है, ठीक है, दैट मींस दिस सर्कल इज रिप्रेजेंटिंग एक्टिविटी ए एंड इट्स ड्यूरेशन इज 2. ये हो गया. और इसके 4 जो क्वाड्रेंट आपको दिख रहे हैं, आपको टॉप में 2 क्वाड्रेंट और बॉटम में 2 क्वाड्रेंट. इसका भी साइन कन्वेंशन के हिसाब से लोकेशन वाइज इसका मीनिंग फिक्स है. तो जैसे टॉप के जो 2 है, दे आर रिप्रेजेंटिंग अर्लीस्ट टाइम, राइट, अर्लीस्ट टाइम. पर आज नीचे का जो दो ब्लॉक्स है या क्वाड्रेंट्स है, दे आर रिप्रेजेंटिंग द लेटेस्ट टाइम. ये डिफरेंस यहाँ पे ये है कि हम उसमें सिर्फ 2 ही टाइम लिखते थे. पहला जो हमारा था एक्टिविटी ऑन आर, इसमें हमको 4 टाइम मेंशन करना पड़ता है, राइट. तो 4 क्या है? earliest start of what? Of this particular activity. ये जो एक्टिविटी की आप बात कर रहे हो, जैसे एक्टिविटी ए है, एक्टिविटी ए earliest स्टार्ट कब हो सकता है? दैट इज ईएस. तो आप वैल्यू यहाँ पे लिखो ईएस ब्लॉक में. earliest फिनिश, वो वेरी ऑब्वियस वैल्यू क्या होगा? ईएस प्लस 2. वो कोई खास डिफरेंट नहीं है. अगर आप earliest स्टार्ट ठीक से लिख दिए तो earliest फिनिश लिखना कोई डिफरेंट नहीं है. यहाँ पे कोई देखिए हाथ से लिखा है ईएस प्लस ड्यूरेशन, ठीक है. तो ड्यूरेशन आपका मान लीजिए 2 है, तो ईएस प्लस 2 हो गया ईएफ. बट इट इज अ साइन कन्वेंशन, तो आपको लिखना पड़ता है, अदरवाइज ए सिंपल एडिशन है, ड्यूरेशन ऐड करके यहाँ लिखना है. सिमिलरली द अदर इंपॉर्टेंट थिंग इज द लेटेस्ट स्टार्ट. ठीक है, लेटेस्ट स्टार्ट ऑफ व्हाट? लेटेस्ट स्टार्ट ऑफ दिस एक्टिविटी. ठीक है, इट इज डिपेंडिंग ऑन द प्रीडिसेसर कब खत्म हो रहा है, तो लेटेस्ट कब स्टार्ट कर सकते हैं, कितना लेट हो सकता है. तो अगर वो वैल्यू आपको पता चल गया लेटेस्ट स्टार्ट, तो लेटेस्ट फिनिश भी वही है, उसमें सिर्फ ड्यूरेशन ऐड करना होगा, क्योंकि वो तो कोई डिफरेंट नहीं होगा. जब ड्यूटी स्टार्ट हो गया सो इट विल जस्ट कंज्यूम द ड्यूरेशन. तो लेटेस्ट फिनिश भी इजीली आप कैलकुलेट कर सकते हो, जैसे आप ऊपर में किए ईएस प्लस ड्यूरेशन. सो दिस द साइन कन्वेंशन दैट इज यूज्ड फॉर एक्टिविटी एंड मोड टाइप ऑफ अप्रोच. ये जैसे यहाँ पे एक एग्जांपल में आपको दिखा दूँ. So this is one network. आप ये नेटवर्क कंस्ट्रक्ट कर लिए यूजिंग एक्टिविटी ऑन नोड. ठीक, एक्टिविटी ऑन, ये हर एक सर्कल एक एक एक्टिविटी को रिप्रेजेंट कर रहा है. आप यहाँ देख सकते हो, यहाँ पे एक स्टार्ट बनाया गया है. ठीक है, एक स्टार्ट है. तो स्टार्ट का जो होगा, स्टार्ट का ऑल द 4 वैल्यूज यू हैव टू यूज एज 0. दे आर बाय डिफॉल्ट दे आर 0. नाउ कमिंग टू एक्टिविटी ए. ठीक है, एक्टिविटी ए का ड्यूरेशन 2 दिया होगा और उसके अर्लीस्ट स्टार्ट और लेटेस्ट स्टार्ट भी बाय डिफॉल्ट 0 ही होगा. ठीक है, जो पहला इवेंट है आपका, पहला एक्टिविटी जो है, ये भी आपका 0 ही आएगा. ठीक है, ओके. ना जो आगे का जो वैल्यू है, जैसे एक्टिविटी ए का अर्लीस्ट फिनिश क्या होगा, दैट विल बी जस्ट 0 प्लस 2. ठीक है, सिमिलरली यू कैन प्रोसीड. लेकिन आपको याद होगा जैसे फॉरवर्ड पास में हम लोग क्या करते थे, जब फॉरवर्ड पास करते थे कोई भी नोड में, जब हम कंपेयर करते थे, तो जो मैक्सिमम वैल्यू आता था, जो अल्टरनेटिव जहाँ पे बन रहा है, जो मैक्सिमम वैल्यू आता था, तो उस मैक्सिमम वैल्यू को लिया जाता था. ठीक है, फर्स्ट डिजिट को फिल करने, फर्स्ट ब्लॉक को फिल करने के लिए. यहाँ पे भी सेम आपको फॉलो करना होगा. जैसे मैं आपको यहाँ दिखा दूँ, जहाँ पे एक से ज्यादा एरो मर्ज हो रहे हैं. कम टू एक्टिविटी डी. ठीक है, एक्टिविटी डी पे आई, डी नीचे वाला लाइन है. एक्टिविटी डी में आप देखिए यहाँ पे 2 एरोज आ रहे हैं. ठीक है, एक बी की तरफ से आ रहा है और एक ए की तरफ से आ रहा है. तो यहाँ पे आपको कंपेयर करना होगा अर्लीस्ट, जब हम फॉरवर्ड पास कर रहे हैं उस समय की बात करना. तो जो अर्लीस्ट स्टार्ट टाइम है, सो दैट विल बी कंपेयर्ड. यहाँ पे आप देख सकते हैं, लिखा हुआ है मैक्सिमम 2,3. तो यहाँ पे 2 अल्टरनेटिव आ रहा है आपका, 2 आ रहा है और 3 आ रहा है. तो उसका मैक्सिमम आपको लेना होगा, क्योंकि जब बी की तरफ से आ रहे हो, बी का एक्टिविटी टाइम 3 है और वो 0 में स्टार्ट हो रहा है, तो ऑब्वियसली अर्लीस्ट स्टार्ट वो 3 दे रहा है. जबकि ए की तरफ से जब आप आ रहे हो, तो उसका अर्लीस्ट स्टार्ट 0 है और उसका एक्टिविटी ड्यूरेशन 2 है. तो मैक्सिमम 2 और 3 में से 3 लेना होगा. सेम प्रिंसिपल इज सेम, but there is little difference in the sign convention. ठीक है, तो इसका आप फर्स्ट फिगर आप देख सकते हैं 3 लिखना होगा एक्टिविटी डी का. दैट इज द अर्लीस्ट स्टार्ट टाइम ऑफ एक्टिविटी डी. अब उसके बाद नेक्स्ट डिजिट तो 7 होगा हमेशा. यू जस्ट हैव टू ऐड द ड्यूरेशन विद दैट. सो 3 + 4 7. नीचे का जो फिगर है वो कब मिलेगा, जब आप बैकवर्ड पास करोगे. अभी नहीं कर सकते. लेटेस्ट टाइम आपको बैकवर्ड पास में मिलेगा. जैसे आप एक्टिविटी ऑन आर्क में किए थे, बैकवर्ड पास में आपको सेकंड डिजिट मिल रहा था, वैसे ही मिलेगा. यहाँ पे डिफरेंस अगर देखा जाए तो डिफरेंस यही है कि आप यहाँ पे 4 फिगर लिख रहे हो, जबकि जो लास्ट दोनों है वो सिर्फ ड्यूरेशन ऐड करके लिख रहे हो. अदरवाइज इट इज सिमिलर. to your backward and forward phase computation that you are doing activity on। तो जैसे आप लास्ट एक्टिविटी में पहुंच गए एच, ठीक है, एच में आप देखिए आपका जो अर्लीस्ट स्टार्ट टाइम हो गया, अर्लीस्ट स्टार्ट टाइम है वो 13 आ गया आपको।
डेटा का राइट हैंड साइड, डेटा का और भतीजा दोनों का चुनाव ब्लेसिंग्स का जरूरत है, बहाना कुछ मत कीजिएगा, सब परिवार आना है तुरंत और लोकेशन हम शेयर कर देंगे। सगुन वही मराबादी वाला बिल रोड है ना, उसी आगे जाके दिव्यांग से और आगे जाके लेफ्ट साइड में लेंगे। और कोई बोलने की जरूरत नहीं सर, एक थैंक यू।
So try to understand the calculation is not different. The only thing is that sign convention is a little bit different. तो जैसे आप एक्टिविटी ऑन आर्क में लास्ट दोनों डिजिट को बाय डिफॉल्ट इक्वल कर देते थे, जो अर्लीस्ट टाइम था उसको लेटेस्ट टाइम भी वही कर देते थे, यहाँ पे भी वही करना होगा आपको। अब देखिए जैसे आपका एच एक्टिविटी में जाइए, एच एक्टिविटी में आपको 13 + 2 15 मिल गया, so 15 हो गया आपका अर्लीस्ट फिनिश टाइम, राइट। जो टॉप का सेकंड डिजिट है 15 है, दैट इज द अर्लीस्ट फिनिश टाइम। तो लॉजिकली आपको क्या करना होगा कि जो लेटेस्ट फिनिश टाइम उसको भी 15 करना होगा। तो आप देखेंगे कि इसके जो नीचे वाला ब्लॉक है उसको भी 15 लिखा गया है, जैसे आप उस समय भी किए थे। Am I audible to you?
Yes sir.
So उसको भी 15 करना होगा, जो अर्लीस्ट फिनिश टाइम एंड लेटेस्ट फिनिश टाइम दोनों को इक्वल करके फिर आप विल मूव बैकवर्ड्स। तो व्हेन विल मूव बैकवर्ड्स तो बस वही ड्यूरेशन माइनस किए 15 - 2, यहाँ पे 13 लिखना होगा। और जिस नोड में आपको मोर देन 2 एरोज का कंपैरिजन कर रहे हैं, जैसे कम टू एक्टिविटी सी में लिखिए, ठीक है। एक्टिविटी सी में जैसे आपको 2 एरोज वहाँ से इमर्ज कर रहा है, तो यहाँ पे आपको कंपेयर करना होगा। तो यहाँ पे आप देखिए लिखा हुआ है मिनिमम ऑफ 4 and 10, क्योंकि बैकवर्ड पास में आपको मिनिमम करना है, ठीक है, बैकवर्ड पास में मिनिमम। और जो 4 डिवाइड किए हैं क्वाड्रेंट आप, नीचे का 2 जो है, नीचे का 2 दैट विल बी फिल्ड व्हेन यू विल मूव बैकवर्ड्स, व्हेन यू विल मूव बैकवर्ड पास। एंड ऊपर का जो 2 है दैट विल बी फिल्ड व्हेन यू विल मूव फॉरवर्ड। सो that basically is the difference between activity on node and activity on arc time kind of calculations. Do you have any questions? Okay, there is another interesting thing you must see. Now after filling all these 4 values, देख सकते हैं जब backward और forward pass हो गया, you can fill all the 4 values. Then how to identify the critical path? Okay? How to identify the critical path? Again, I'll advise you that the best method, the most secure and foolproof method is that you find all the alternative paths between the start and the end. ठीक है, ये एच के बाद आप एक एंड भी बना सकते हो, ठीक है, यहाँ पे नहीं बना गया है, एच के बाद एक एंड भी बना सकते हो। So you can find all the alternative paths and you just check what is the addition of the activity durations along all these paths. जैसे यहाँ पे एक पाथ आपका हो रहा है ACFH और एक हो रहा है ACEGH और हो रहा है ADGH और हो रहा है BDGH, ठीक है। तो जितने भी अल्टरनेटिव पाथ है आप इसको आइडेंटिफाई कीजिए और सबका एक्टिविटी ड्यूरेशन ऐड कीजिए। आप देखेंगे इसमें कोई एक पाथ होगा, एटलीस्ट एक पाथ होगा, या मे बी मोर देन 1 पाथ। अगर मल्टीपल क्रिटिकल पाथ्स है which will give you 15, right, which will give you 15 as the total ड्यूरेशन जब सारे एक्टिविटी को आप ऐड कर देंगे। तो इस केस में आप देखेंगे, अगर ध्यान से देखेंगे, there are some arrows which are having two arrow heads, थोड़ा बोल्ड भी है उस लाइन को किया गया है, देख सकते हैं। जैसे स्टार्ट से लेके ए तक, ए से सी तक, सी से ई तक, वो जो एरोज यूज किया गया है वो थोड़ा डबल एरो हेडेड है और थोड़ा बोल्ड भी है, बिकॉज दैट इज रिप्रेजेंटिंग the critical path here. Right? That is representing the critical path. क्योंकि आप उसका duration ऐड कीजिए, जैसे A का 2, C का 2, 2 plus 2 4, 4 plus 4 8, 8 plus 5 13. ठीक है, तो 13 plus H का भी ऐड करना पड़ेगा because H is an activity now. तो 13 plus 2 15. अब देखिए प्रोजेक्ट कंप्लीशन टाइम इज 15. ये जो 15 है आपका H एक्टिविटी में जो आप लिखे हैं ना, earliest finish, that in fact is the project completion time. So वही एक पाथ है जिसमें आपका टोटल एक्टिविटी ड्यूरेशन 15 हो रहा है और बाकी कोई भी पाथ यूज कीजिए 15 से कम होगा. ठीक है ना, सेम प्रिंसिपल इज सेम बट ओनली the sign convention and the approach is different, right? But as I said in the previous classes some time back that most of the software make use of this kind of AON और उसको एक ब्लॉक में रिप्रेजेंट करते थे. जैसे मैं लास्ट स्लाइड में दिखाया था कि AON का एग्जांपल और उसमें काफी सारे डिटेल्स थे. So that is maybe a screenshot from Microsoft project software. So उसमें बहुत सारा डिटेल रहेगा, वही early start, early finish, latest start, latest finish, activity duration या और कोई एक्टिविटी का कोई आइडेंटिफिकेशन आईडी होता है हर एक एक्टिविटी का. So something more detailed one can give, but the approach is same, the principle is same, right? So is it clear how AON is different than AOA? Is it clear or do you have any questions?
Clear, sir.
Okay, good. So with this, I think the syllabus of module 4 is now complete, right? Syllabus of module 4 is now complete. I have already given you the material and I will share this PDF also. Maybe some portions you can go through. Today itself I will share this PDF. So with this we completed the module 4. Now we have decided the quiz for that also. Okay. Now let me, it is only 9:35, so I will begin the module 5 a little bit, right? So just give me a second. I will share the PPT for module 5. Okay, so these two modules are in fact not much different. The only difference is that in module 5 we will come to know about another method of network analysis, which is again related to project scheduling, and that is called PERT, P-E-R-T, PERT. In fact, that is also a network analysis, but it is different than the method that we have discussed, that is called CPM, right? What method we have discussed is called CPM. What is the full form of CPM? Anyone? What is CPM? Communist Party, Marxist. Critical path method, right? Critical path method is CPM, and in module 5 we will discuss another method which is called PERT. PERT stands for Program Evaluation Review Technique. Can you see module 5 slide? Okay, can you see this slide for module 5? And I'm showing.
Yes, sir.
Okay. So basically, it's a very small portion in module 5, and I'll try to make it convenient for you as much as possible. I'll not put more pressure into it. So, okay. So whatever 2-3 classes we are left with, hopefully we will be able to discuss it comfortably. So we'll talk about something called normal versus crashing of the project in the beginning. Then we'll go for the time cost trade-off, and then finally we'll discuss the PERT method at the end. Is there? Yes, PERT is at the end. So let me begin with this particular concept, which is called normal versus crashing a project. So just listen to me carefully. What happens actually, say in real life, sometimes the project manager may think to reduce the time spent on a project, right? Because of many reasons, because of some emergencies, because of some other pressing needs, you are ready to spend more on that. Right? If you want to crash it or reduce its time duration, you need to spend more. Spend means you may have to use more machines, maybe different materials which are costly, or maybe put in more manpower. Right? So by various means, you need to compress the time so that you will be able to complete the project before the due date, something which is required. So when you are doing this, you are talking this as a crashing of a project, right? If you are doing the things normally without putting more resources, then it is normal duration. And if you are putting more cost, more resources, then obviously it will become costly. But you are reducing the time, so that's called crashing of the project. Now, reducing both the project cost and time is critical in today's market-driven economy. This relationship between project's time and cost is called time-cost trade-off decision. So, why it is called trade-off? Actually, now you can imagine there are two factors. One is the time, which is the schedule, and the other is the cost. Right now, you got an idea that if you are spending more, the time will be compressed. You can complete it earlier. But is it always advisable to compress it to the minimum value at a high cost? May not be. May not be. So this is the kind of conflict in the objective, or kind of trade-off between these objectives. So what is the middle path? What is the middle path, or what is the balance between these trade-off? That has to be taken. Right? Blindly, you just cannot spend more on these project activities or project investments or resources just to reduce time, right? It may not be economically viable option for you. So this is called time cost trade-off decision, right? So there must be a best solution. That if you can compress the time to that value, then both the time wise as well as the cost wise, you are taking the best decision. So that is called time cost trade-off decision, right? Crashing an activity refers to taking special costly measures to reduce the duration of an activity below its normal value. That's what I said. So these special measures might include using overtime, hiring additional temporary help, using special time-saving materials, obtaining special equipment, etc. So these are various means by which you can reduce the estimated time of any activity, but at a cost. Crashing the project refers to crashing a number of activities in order. Okay, so crashing of activity means you are crashing a single activity, right? See, crashing is not a new term. You already have experience of crash courses, right? So maybe the same content is delivered within a short time. That is crash course. So same thing happens in project activities. So when you are crashing the various activities of a project, that you are saying you are crashing the whole project, right? So this is in order to reduce the duration of the project below its normal value, right? So if you are doing the things normally, then the cost will be less compared to the crashing cost, right? So the crashing time is less than normal time, but crashing cost is more than the normal cost, right? So these two things are trade-off. The activity duration can be reduced by any one of the following actions. Depends how this crashing takes place, how you are reducing the time. Applying multiple shift works, right? Working extended hours, that is overtime. Offering incentive payments to increase the productivity. You will offer incentives to the workers or operators. Their productivity will increase, the human psychology. Working on weekends and holidays, right? You stop all the holidays and weekends and you make them work, so it will be completed before time. So these are various ways in which means through which you can use it. Using additional resources. Instead of suppose you have only one excavator, you bring in two more excavators or any other machines like mixing machines or any other equipment. Maybe sometimes it will change the material, which are having a faster solidification or installation methods. Then maybe it reduces time, right? But it may cost you. So using alternate construction methods, maybe for it is applicable for civil projects, but maybe applicable to each and every project. There must be some ways in which you can reduce the time using a different approach or method, which will be expensive. The time cost trade-off decisions are complex and require selection of appropriate method for each project task. Time cost trade-off, in fact, is an important management tool for overcoming one of the critical path method limitations of being unable to bring the project schedule to a specified duration. So this time cost trade-off, if you are ignoring, that means you are ignoring a big advantage of your project, right? See, why you have done the CPM, the critical path method? The reason is that you have identified the critical activities which are deciding the overall project completion time, right? Now, what is the next step? The next step is effectively how to reduce the duration of those critical activities so that the project will be completed earlier. See, in any case, if the project is getting completed earlier, it is definitely advantageous in many ways, right? Suppose you have competitors, you are producing a result before that. Let us say you are doing some R&D activities, right? And there are many competitors are also doing the same R&D kind of activities. So here time plays a big role. If you can find the result earlier, you are the winner. You will have the patent. You will have the commercialization. So, I mean, many times it is very much advantageous to the company to complete the project as soon as possible, right? So in that case, if you have done the CPM, then you identify the critical path and the activities. Then work on those activities and try to find how to crash them so that you can complete the project before the schedule time. That is the main application or use or utilization of your CPM. Okay, now this interesting figure you can see here. It's a small graph, and that is representing this time cost. Your x-axis is representing duration, that is the time, and your y-axis is representing money, the cost. So here you can see that two situations are marked here in the plot, that is crash and normal, and a straight line is connected. So crash is a situation where the time is less, you can see that is the crash time, and the corresponding cost is more. It's called crash cost. Similarly, the second point is a normal point, and its corresponding time is normal time, which is definitely longer than the crash time on the x-axis. But the corresponding cost is normal cost, which is definitely less than the crash cost. So this is a simple logic which works behind this time cost trade-off. The CPM method of time cost trade-off is concerned with determining how much, if any, to crash each of the activities in order to reduce the anticipated duration of the project to a desired value. Right? Now, as I said, whatever time is available with the activities which you can crash, is it always advisable to crash it to the fullest? Means whatever is available, is it advisable to crash it fullest, or there is some best solution in between? Because when you are crashing it, you are spending more on it. The crash cost is more. So it is not that practically you have to crash each and every activity to the fullest of its capability, right? It is not advisable. Economically, it is not advisable. You will spend a lot. That is what we will see in this discussion. Maybe in the next class we will discuss that further. This is the background only. So the data necessary for determining how much to crash a particular activity are given by the time cost graph of that activity. So each activity, I repeat it, for each activity, there is a time cost graph like this. For each activity, if there are n number of activities, you have n number of such graphs. And what this graph represents, see, each activity is unique. Unique in the sense it deals with a different kind nature of work. Digging up the foundation is not same as plastering of the walls. They are completely different nature of walls. It needs different machines, different materials, different skills levels of workers and all that. So for each and every activity, there is a unique and particular type of time cost graph, just like I have shown in the left right hand side. The slope of this particular line, which represents that particular activity, will vary from activity to activity. Different activity will have different slopes, right? Slopes means the inclination. If the inclination is less, what does that mean? That means you are able to reduce the time by spending less, isn't it? Because inclinational less means the difference in the ordinates is less. On the y-axis, it is less. So if the difference in y-axis is less, that delta y is less, that means that you are spending less. The difference between crash cost and normal cost is less compared to the gain you are getting in the time, that is on the x-axis, del x. So that slope represents that nature of that activity. If it is steeper, that means just to reduce 1 or 2 days, you have to spend a lot, because that is the nature of that work. So that is taken into account now. That is taken into account too. That which activity to reduce and by how much to reduce. See, you cannot spend as much as you like. So that's right. You have to look into the slope of this line, of this time curve graph, and on the basis of that, we'll try to decide that which activity to be crashed and by how much. How much means how many days or weeks. It's not that whatever is available to crash, you will crash it blindly. So that will not economically best solution for you. So these things are there in the time cost trade-off discussion of project management. All right. So these points I have discussed. Normal point for an activity, and the cost of the activity is the normal cost. Similarly, there is a crash point, and so is the time cost when the activity is fully crashed. Fully crashed means you cannot further reduce the time. See, practically, no matter how much the extra resource you use, there must be a limit to the time duration. You cannot reduce it further, right? There is a technical limitation for each and every activity. Otherwise, if you have money, you could have completed the project within 1 day, but it is not possible. There are activities that will need time. You cannot make it faster than that, no matter how much resources you use. So that is called fully crashed. Fully crashed means it cannot be reduced further. Right? Okay, so do you have any questions up to now? For most applications, it is found that, okay, this is also interesting. So in most of the applications, you will find that partially crashing the activity at any level will give a combination of time and cost that will lie somewhere on the line segment between these 2 points. So in most of the cases, you will find that partial crashing will give you the best solution, means cost-wise and time-wise. So these are the 2 objectives you are maximizing, time and cost. So therefore, it is found that partial crashing is much useful. Okay, so this I'll stop here.